So piecewise defined functions are going to be an important part as we move into the next section. So let's practice some more. So what do we know about the square root of x squared? We know that means the absolute value of x. Oh, so if I was to break this up into two functions, this would be absolute value of x over x. We know what that graph is. It's that graph. So here's 1, here's -1. Okay, so if I was to put together the solution graph, I would have this, right? -1 and 1, because I don't include 0. And then what does this say? When x is 0, I use the y value of 2. So I've got this flying dot up there. Is it a function? Yes, because if I do the vertical line test, it only touches one point at every point. Okay, so root -x. Okay, so this means it's a reflection across the y-axis, so that's what the graph looks like. And we want all x's that are less than 0. So I'm not including 0, and I'm moving back in that way, right? E to the -x is a flip across the y-axis also. So here it crosses at 1. So if I'm using x is bigger than or equal to 1, I start here at the point 1 and move up. All right. Ooh, this combines a lot of things. What does this mean? So this means x's are between 1 and -1, right? Absolute value means distance from the origin. So let's look at the x to the 2/3 graph. Looks like that. And I want between -1 and 1, not including the endpoints. And I know that both of those will give me a y value of 1. So let's put them over here on the solution graph. So that's what this part of the graph is going to look like. All right, this means distance from the origin is bigger than 1. So this is x is bigger than or equal to 1, or x is less than or equal to -1. So what does this graph look like? 1 over x squared looks like this. So I'm picking out 1, and I'm going to include that point and go out this way. And I'm going to include this point and go out this way. So the y value associated is 1. That's the same point. So don't include wins, right? Include wins. So that's the solution graph. Okay, so you know when you have something like this, this graph here, you want to factor it. Okay, so this simplifies to x plus 3, but you know there's a hole when x minus 3 equals 0 or when x equals 3. So I'm going to graph this line, y equal x plus 3, so there's the y-intercept 3, that 3. When x equals 3, down here, that's where I make the hole. And what's the y value for the hole? If I put 3 into here, I get that the y value is 6. Okay, so that's where the hole is. This says when x equals 3, I'm going to put a filled in dot there, right at 5. Okay, so let's look at this one. So this, if I simplified it, x minus 3, x minus 3, x plus 3, I cancel the x minus 3, so I get 1 over x plus 3. But there's going to be a hole when x minus 3 equals 0 or at x equals 3. So we know this has an asymptote at -3. So that's what this is saying. Don't use -3. And I know this will be the hyperbola that comes, but I'm going to have a hole at x equals 3. So let me just first this out further. So here's 3, and that's where the hole is. So what's the y value of that hole? If I put 3 into here, I get a y value of 1/6, right? Okay, so when x is equal to 3, there's a filled in dot at 2. And when x is -3, there's a filled in dot at 4. That's kind of weird on an asymptote, right? Okay, let's just finish these last couple off. So if I'm trying to find where these two intersect, so this is a parabola and a line. So you can see they intersect. So we know we set them equal to each other, right? because it's a quadratic, we get it equal to 0. Then we factor. And so I get x is 3 and negative 2. And so if I was to find the intersecting points, right, I would put 3 back into either one of those points, right? So if I put x equals 3 into here, I would get the point 3, 9. And if I put the x equals negative 2 in here, I get negative 2, 4. And that's what those 2 points would be. Ooh, x equal y squared. That's a graph I want you to know. And I wouldn't know how to graph this by myself, like the way it's written. I would, if I was to graph it, not that you, it does say do. So negative 2y equals x minus 8. So divide through by negative 1/2. So this gives, whoops, 1/2 x, right? Divide through by negative 1/2. Slope of negative 1/2, y-intercept of 4 looks something like this. So I see those 2 points. So let's set the x's equal to each other. So I get y squared equals negative 2y plus 8. Because it's a quadratic, we want to get it equal to 0. So plus 2y minus 8 equals 0. So y plus 4, y minus 2. And so I get y equal negative 4 and 2. Okay, so if I was to find the xy points, I could plug this y equal negative 4 into here. So then if I plugged in y equal negative 4, I get 16, negative 4. And if I plug y equal 2 into here, I'd get 4, 2. Okay, let's look at these two. X cubed and x squared. So if you were to draw them, you'd think, what? Where's the point? I don't see it. But zoom in on this, and if you think about it, between 0 and 1. So if this was x squared, right? If I put in 1/2, this would give me the y value of 1/4, right? Yeah, sorry, that's a great picture. Y value 1/2. This would give me a y value of 1/4, which would be here, right? And there's 1 and 1. Okay. If I was to use y equal x cubed, think about it. Where would the y value for x cubed be? That would be 1/8. That's smaller, right? So it comes through here, down here, goes through the same point 1, 1. So I'm exaggerating it, but you can see this is below. So if I set x cubed equal to x squared, you know, don't divide by variables. Factor out an x squared. And so what I get as solutions is x equals 0 and x equal 1. So that gives me the 0.00 and the 0.11. Last one. Okay, 1 over x looks like this. 1 over x squared looks like this. What? Do they intersect? Let's check out that point again. So there's 1, 1. And this has the point 1, 1 also. So let's look at what happens when we plug in 2. If I plug in 2 into here, I get 1/2, right? If I plug 2 into here, I get 1/4. So this graph here, 1 over x squared, crosses through here but goes below, right? And this is going to be important. We're going to need to know this. So if I set 1 over x equal to 1 over x squared, multiply through by x squared, then I want to subtract, get equal to 0. So I get x times x minus 1. So from here, I get x equals 0 and 1. So the two intersection points. Wait a minute. Do they intersect at 0? They do not. So they intersect at 1.11.